So we're going to take a look at Billy's method of factoring. Now, Billy's method of factoring is used when we have a number in front of my x squared that isn't a 1 and is not a greatest common factor. So 4 does not go into 3, which keeps it from being a greatest common factor. So I want to factor this problem, but I can't use my fast foiling, so here's where I use Billy's method. I start by taking the a and the c, multiplying them together. So 4 times positive 3 is positive 12. Now I'm going to list my factors of 12. 1 and 12, 2 and 6, 3 and 4. And I'm looking for the two factors that will add to get my b, my negative 8. Well, that's 2 and 6, if it's negative 2 and negative 6. And that's okay because negative 2 times negative 6 is a positive 12. Once I find those two factors, I make them into fractions. I put them both over my leading coefficient with an x attached to it. So they're both over this 4x. Now I'm going to reduce fractions. Negative 1 over 2x. Negative 3 over 2x. And last but not least, I'm going to write my two sets of parentheses, starting from the bottom of the reduced fraction to the top, 2x minus 1, 2x minus 3, and that is my factored form. Let's try that again. So I see that 5 there. It's not a GCF. So 5 times 3 is 15. My factors of 15, 1 and 15, 3 and 5. 1 and 15 will work if they're both negative. I'll put them both over the leading coefficient of 5x. This one is already simplified. This one can be simplified to negative 3 over x. My factored form is 5x minus 1 times x minus 3. So it's really very easy. One more example where it certainly gets a little more complicated. You just have to remember that all of the other things we learned with factoring still need to be true. So I still need to look for a GCF, which in this case is 2. So I'm going to take that 2 out. I'm left with 2x squared plus 1x minus 3. Now that 2 is just going to follow my problem down to the end. So in essence, I can kind of ignore it and just look at what's inside those parentheses. Well, I'm going to have to use Billy's method because of the leading coefficient not being a 1. So 2 times negative 3 is negative 6. 6 and 1, 3 and 2. Positive 3 and a negative 2 make positive 1. So positive 3, negative 2. Put them both over 2x. This remains the same. This reduces to negative 1 over x. So now I have 2x plus 3 and x minus 1. And I just remember that GCF has got to be written in front so that we can get back to the original problem. So that if I now FOILed and then distributed the 2, I'd be able to get all the way back to my original expression.